Welcome back to Simultaneous Linear Equations. In this video, we are going to look at what I like to call the boat problem. Before that, however, I'd like to introduce the concept of relative speed. Imagine you're running on a treadmill and the treadmill shows that your speed is 10 kilometers per hour. But what is your relative speed? Your relative speed will be 0, because even though you're running at 10 kilometers per hour, you're not actually moving anywhere. You're not going forwards or backwards. You're in the same place. So your relative speed is going to be 0. Now in the boat problem, you have this river which is flowing in a particular direction with some speed. So let us say it's flowing in this direction with speed y, and there is a boat on the river whose speed in still water is equal to x. That means that if the river was not moving, then the speed of the boat would equal to x. Now in your examination, there are only two possible directions that the boat can move. One is called upstream. In this case, the boat and the river move in opposite directions. So the relative speed of the boat is going to be slower, and it is given by the difference between the speed of the boat and the speed of the river, x minus y. The other possible direction that the boat can move in your examination is called downstream. And in this case, both the boat and the river move in the same direction. So here the relative speed of the boat is going to be faster, x plus y, the sum of the speeds of the boat and the river. Now in such problems, I want you to use this formula, speed equals distance upon time. In your textbook, they've given a slightly different version. They write time equals distance upon speed. Now that version of the formula makes the solution of these problems unnecessarily complicated and lengthy. So don't use the formula given in the solved examples in your textbook. Use this version of the formula, speed equals distance upon time. The reason is because we have two equations for speed, one for upstream, one for downstream. So with the information given in the question, you can write two very simple linear equations. For upstream, you can write x minus y equals something. For downstream, you can write x plus y equals something. And these equations are extremely simple to solve. You just add them together, the y terms cancel out, and you can find the value of x. And then you substitute the value of x in either equation to find the value of y. And you have your final answer. So don't use the method in the textbook. Use this formula, speed is equal to distance upon time. Now let us solve an actual problem based on this. So problem 5 states, a boat travels 5 kilometers upstream in 5 hours and 7 kilometers downstream in 1 hour. Find the speed of the boat in still water and the speed of the stream. So we begin by writing, let the speed of the boat in still water be x and the speed of the stream be y, that is the speed of the river is y. Then we will write the formulae or the equations for the speed of the boat upstream and the speed of the boat downstream. So we'll say therefore speed of the boat upstream is x minus y, the difference in the speed of the boat and the river, and speed of the boat downstream is equal to x plus y, the sum of the speeds of the boat and the river. Now that we've written this, we write our formula which relates speed, distance and time. We say now speed equals distance upon time, and then we plug in the given information. So first we are told about upstream. It goes 5 kilometers distance in time of 5 hours. And we know the speed upstream is x minus y. So with all this information we can write x minus y is equal to 5 upon 5 is equal to 1. Then we look at the information given for downstream. We are told the distance is 7 kilometers and the time is 1 hour, and the speed we have found is x plus y. So our next linear equation is x plus y equals 7 upon 1, which is equal to 7. These are equations 1 and 2. Now all we have to do is add them up together. That will cancel out the y's and give us the value of x. So adding 1 and 2, we get 2x is equal to 1 plus 7 is equal to 8. Therefore, x is equal to 4. And now we can plug this value of x in either of the equations. So we say substituting in equation 1, we will get 4 minus y is equal to 1. Therefore, y will equal to 4 minus 1, which is equal to 3. And we have solved our problem. We have found x, which is the speed of the boat in still water, and y, which is the speed of the stream. Therefore, the speed of the boat in still water is 4 kilometers per hour and the speed of the stream is 3 kilometers per hour. So I hope you found this really simple. I would suggest that you look at the solution given in the solved examples in your textbook and see how complicated and difficult that is. And then you can appreciate how simple this method is. So with this, we come to the end of this video. Thank you for watching, and I'll see you in the next video.